13.1, day number 2 notes, more practice with some identity work. Let's get started. Just a reminder, this is a review slide from the previous day's lesson. Some important information there. Also, our identities here, as well as your hints. So please look back at day number 1 notes if you want a reminder on those hints. So let's go ahead and get started. Okay, problem number 1 of our practice problems here. First thing that jumps off the page at me is this right here, and this is an identity. 1 plus cotangent squared theta is equal to cosecant squared theta. So I'm going to work on this left side here. I'm going to have cosecant of theta over cosecant theta over cosecant squared theta. And if you take, like we did yesterday, x over x squared, that reduces to 1 over x. So here, cosecant over cosecant squared is 1 over cosecant, which, conveniently, cosecant is the reciprocal of sine, and therefore, we're done. Okay, let's see what we get here in number 2. Right side would be definitely the more complicated of the two. There are a couple rabbit trails you could go down. You could turn secant squared into 1 plus tangent squared. But please take a look at what you would get. Right? And this will get you the right answer eventually. Does anybody feel like taking that to the 4th power and using the binomial expansion? I don't think so. So what I would suggest, conveniently, check this out. Secant squared theta equals 1 plus tangent squared theta. And that looks like a 1 plus tangent squared theta. Now, there are some hidden clues here. If you look on the left side of this formula, or this equation, what you'll notice is that we're looking to get it in terms of secant. So I would say this is the best way to go. That's going to be secant squared theta, based on one of our identities, to the 4th times secant squared theta. Now, just to parallel this, I want to look at this. What would that be? Well, that would be x to the 8th times x to the 2nd, which is x to the 10th. We add those exponents. Ooh, secant to the 10th. So what I would do is I would then call this secant to the 8th theta. This here would stay the same, secant to the 2nd theta. And this is no different than exponents with a variable base x, base whatever we want it to be. This would be secant to the 10th. So I take this 8 and I take that 2 and I add them together. I get secant to the 10th. Okay, keep moving. All right, we're now into the homework. I'm not going to do number 86. That one should go pretty well for you. But I do want to jump into number 104 here. Okay, so the more complicated side that I'm seeing is the right side here. So I'm going to rewrite that in terms of cosine. So 1 plus secant will be 1 plus 1 over cosine. The denominator will be 1 minus 1 over cosine. Okay, now, 1 here and 1 here are both equal to cosine theta over cosine theta. So in the numerator, I have cosine theta over cosine theta plus 1 over cosine theta. In the denominator, I'm going to have the same thing, cosine theta over cosine theta minus 1 over cosine theta. So what did I do? I did one of those hints and I got a common denominator. Right? All right, now let's do a little bit of work. Numerator-wise, I would have since I have a common denominator, I had cosine theta plus 1 over cosine theta. In the denominator, I have cosine theta minus 1 over cosine theta. Now you'll notice these two cosine thetas, they will cancel, and what we'll get is cosine theta plus 1 over cosine theta minus 1, which I believe is what we're looking for. Hold on, let me confirm. Sometimes you can forget what you're actually trying to prove here. Boom, we are done. Okay, so that'd be a common denominator problem. Let's keep doing a couple more. Okay. So let's take a stab at number 120. I'm going to start on the left side of the equation. And the first thing I'm going to do is I'm going to write that left side of the equation in terms of sine and cosine. So this would be 1 over the sine of theta minus cotangent is cosine theta over sine theta. Let me do a quick rewrite on that. So in the numerator, I'd still have a 1. In the denominator, since I have a common denominator in the denominator, you'll see I have the sine in the denominator. I'm going to take 1 minus cosine theta over sine theta. Now, if I had 1 over 1/2, we talked about that being equal to 2. All right, so it'd be equal to the reciprocal of the denominator. So I could do a basically a flip of the denominator and put it in the numerator. Now that might not make sense to you. Let me do it over here. So if I had 1 over 1 minus cosine theta over sine theta, instead of dividing by a fraction, we're told that we can multiply by the reciprocal, right? So I'd multiply by sine theta over 1 minus cosine theta. Same thing up here, sine theta over 1 minus cosine theta. And when you multiply by the reciprocal, what happens is the denominator, it cancels, and this is what I would get, right? So I flip the denominator and put it in the numerator, multiply it by the number up there. So what we've got here now is this sine theta over 1 minus cosine theta. Now, where do you go from there, okay, right? Because that's not what we have. We have cosecant theta plus cotangent theta. And someone is going to be tempted to split this up. And this is not algebraically true. Someone is going to do this, right? And that is totally not right. Right? You can't split up a binomial in the denominator. You can't do that. Okay, so that's not going to work. So here's where you're going to get your first taste of what's called the conjugate. Okay, so I'm going to move that over. When I multiply something by its conjugate, so for example, x minus 4, if I multiply it by its conjugate is this. And there's a reason we use this. It's very, very useful. We do the same thing, x and 4, but instead of a minus, we put a plus. Because when we FOIL that, check out what happens. I get x squared, I get 4x, I get minus 4x, and then I get minus 16. What happens, right, this is the FOILing process, okay, is that these two terms always cancel when you're multiplying conjugates. So one thing that I like to, or helps me remember, is that old people love conjugates. Okay, old people love conjugates. I'm not going to write it all the way out. Why? You're asking me why. Well, the FOIL process, this is kind of a fun way to remember, the FOIL process doesn't require you to do the entire FOIL. What would I get rid of? O and I, right? So what does that remind old people of? Florida, FL, right? You just have to do first last. So what would be the conjugate of 1 minus cosine theta? Okay, so let's check it out. What would be the conjugate of 1 minus cosine theta? Well, it'd be 1 plus cosine theta. So I don't have to FOIL. I just have to Florida. What does Florida mean? That means first times first. First times first is 1. And last times last. Well, that would be negative cosine squared theta. So for my first, I got 1. For my last, I got negative cosine squared theta. I don't need to do outside inside because they are conjugates. So let's see what we get when we do this. What would our denominator now be? Well, we already determined that. It's going to be 1 minus cosine squared theta. What would our numerator be? Well, here's what I'm going to do. I'm going to leave it in this form sine theta 1 plus cosine theta for a moment, and then you'll see why in just a minute. Okay, so now where do I go? Because I'm looking for, what is it, cosecant plus cotangent, maybe, something like that. I don't see cosecant, cotangent, but I actually do, because I have to backtrack to one of my identities that I previously knew. And 1 minus cosine squared theta. Okay, let me rewrite the numerator real quick. Okay, while I'm doing that, you could probably be thinking, but that is going to be sine squared theta. Now, almost there. We're almost there. What would happen with a sine squared in the bottom and a sine on top? Well, what would happen is the sine would cancel with one of these signs down here. So I'm going to get 1 plus cosine theta over sine theta, and we are so close. Now it is legal to do this. I can split this up if there's only one term in the denominator. Okay, what is 1 over sine theta? Cosecant theta. What is cosine over sine theta? Cotangent theta. And I believe, I don't really want to write it all again, but I will because I get paid a lot of money to do this, so I might as well. We are done. Let's maybe do one more. You know what? I'm good there. Yeah, that is day number 2. I did pretty much all of the homework. If you're watching this, then go back and try the problems that I haven't done. Number 124 is a really good one. I would start, if I were you, on this side and work my way back to the left side. Of course, reminder, just pay attention to the rules of only working on one side in any given problem. Like, subscribe, comment below. See you soon.